Let us learn about binomial probability. Binomial probability distribution. The binomial distribution is a commonly used discrete distribution in statistics. The normal distribution as opposed to a binomial distribution is a continuous distribution. There are two parameters n and p used here in a binomial distribution. The variable n states the number of times the experiment runs and the variable p tells the probability of any one outcome. The binomial distribution represents the probability for x successes of an experiment in n trials given a success probability p for each trial at the experiment. The binomial distribution forms the base for the famous binomial test of statistical importance, a test that has a single outcome such as success or failure is also called a Bernoulli trial or Bernoulli experiment, and a series of outcomes is called a Bernoulli process. So consider an experiment where each time a question is asked for a yes or no with a series of n experiments. Then in the binomial probability distribution, the Boolean valued outcome, the success or yes or true or 1, is represented with probability p, and the failure or no or false or 0 with probability q, that is q is equal to 1 minus p. In a single experiment when n is equal to 1, the binomial distribution is called a Bernoulli distribution. Negative binomial distribution. In probability theory and statistics, the number of successes in a series of independent and identically distributed Bernoulli trials before a particularized number of failure happens. It is termed as the negative binomial distribution. So here the number of failures is denoted by R. For instance, if we throw a dice and determine the occurrence of 1 as a failure and all non-ones as successes. Now, if we throw a dice frequently until 1 appears the third time, that is, R is equal to 3 failures, then the probability distribution of the number of non-ones that arrived would be the negative binomial distribution. The binomial distribution formula is for any random variable x. It's given by p of x is to n comma p is equal to n c x p to the power of x 1 minus p to the power of n minus x, or it can also be represented as n c x p to the power of x and q to the power of n minus x, where n is equal to the number of experiments, x is equal to 0, 1, 2, 3, 4, etc. P is equal to probability of success in a single experiment. Q is equal to probability of failure in a single experiment. NCX is the combination of n and x. A combination is the number of ways to choose a sample of x elements from a set of n distinct objects where order does not matter and replacements are not allowed. Note that NCX is equal to n factorial divided by r factorial into n minus r factorial. So for example, 4 factorial is equal to 4 into 3 into 2 into 1. Binomial distribution, mean and variance formula. For a binomial distribution, the mean, variance and standard deviation for the given number of successes are represented using the formulas mean mu is equal to np, variance sigma square is equal to npq, standard deviation sigma is equal to root of npq, where p is the probability of success, q is the probability of failure, and q is equal to 1 minus p. The mean of the binomial distribution is np and the variance is the binomial distribution is np into 1 minus p. When p is equal to 0.5, the distribution is symmetric around the mean, such as when flipping a coin, because the chances of getting head or tail is 50% or 0.5. When p is greater than 0.5, the distribution curve is skewed to the left. When p is less than 0.5, the distribution curve is skewed to the right. Binomial distribution versus normal distribution. The main difference between the binomial distribution and the normal distribution is that binomial distribution is discrete, whereas the normal distribution is continuous. It means that the binomial distribution has a finite amount of events, whereas the normal distribution has an infinite number of events. In case if the sample size for the binomial distribution is very large, then the distribution curve for the binomial distribution is similar to the normal distribution curve. Properties of binomial distribution. There are two possible outcomes, true or false, success or failure, yes or no. There is n number of independent trials or a fixed number of n times repeated trials. The probability of success or failure remains the same for each trial. Only the number of success is calculated out of n independent trials. Every trial is an independent trial, which means the outcome of one trial does not affect the outcome of another trial. Now we will see how to work a binomial distribution formula. So example 1, the question is that 80% of people who purchase pet insurance are women. If 9 pet insurance owners are randomly selected, find the probability that exactly 6 are women. So first step is that identify n from the problem. Using our example question, so n is the number of randomly selected items. So here in the question, it is mentioned as 9 pet insurance. So n is equal to 9. Next step is to identify x from the problem. So x given in the question is 6. And next step is to work the first part of the formula. So the first part of the formula is n factorial divided by n minus x factorial into x factorial. Substitute your variables n 9 factorial divided by 9 minus 6 factorial into 6 factorial, which is equals to 84. When you simplify the equation, the answer will be 84. The next step is to find P and Q. P is the probability of success and Q is the probability of failure. We are given P is equal to 80% or can be represented as 0.8. So the probability of failure is 1 minus 0.8, that is 0.2, that is equal to 20%. The next step is to work the second part of the formula, that is p to the power x, which is equal to 0.8 to the power of 6, and that gives the value as 0.262144. And the next step is to work the third part of the formula, that is q to the power of n minus x, which is equal to 0.2 to the power of 9 minus 6, which is equal to 0.2 power 3, which gives the answer as 0.008. The next step is that to multiply your answer from step 3, 5 and 6 together, so you get the value of 0.176. Now we can learn another example. The question is, a fair coin is tossed 10 times. What are the probability of getting exactly 6 heads and at least 6 heads? Solution is that let x denote the number of heads in an experiment. So the number of times the coin tossed is 10, hence n is equal to 10. The probability of getting head, that is p, is equal to 1 by 2. The probability of getting a tail, q, is equal to 1 minus p, which is equal to 1 by 2. The binomial distribution is given by the formula p of x is equal to ncx p to the power x q to the power of n minus x, and therefore it can be represented as p of x is equal to 10cx 1 by 2 to the power of x 1 by 2 to the power of 10 minus x. According to the question, the first we have to find the probability of getting exactly 6 head. P of x is equal to 6 is equal to 10c6 1 by 2 to the power of 6, 1 by 2 to the power of 10 minus 6, which is equal to 105 divided by 512. Hence, the probability of getting exactly 6 head is 105 divided by 512. The next question is that the probability of getting at least 6 head, which is p of x greater than or is equal to 6. So which is equal to p of x is equal to 6 plus p of x is equal to 7 plus p of x is equal to 8 plus p of x is equal to 9 plus p of x is equal to 10. So which is given and substituted as 10c6 1 by 2 to the power of 10 plus 10c7 1 by 2 to the power of 10 plus 10c8 1 by 2 to the power of 10 plus 10c9 1 by 2 to the power of 10 plus 10c10 1 by 2 to the power of 10. So which gives the value as 193 divided by 512. Binomial distribution gives the possibility of different set of outcomes. In real life, the concept is used for finding the quantity of raw and used materials while making a product. Taking a survey of positive and negative reviews from the public for any specific product or place. By using the yes or no survey, we can check whether the number of persons views the particular channel. To find the number of male and female employees in an organization. The number of votes collected by a candidate in an election is counted based on 0 or 1 probability. Thank you.